All right. This is probably the most challenging question in the packet, and it's harder than anything you're going to see on your test, but it is just a basic titration. It's just that we're solving for a weird unknown. Let's keep track of everything that we do know, though. We know what the concentration is of my oxalic acid, and we know that my oxalic acid is in the flask. So in my flask, right here, I have a concentration of 0.803 molar, and I also know that it is 20 milliliters in there. That's a little small. 20.00 milliliters. And then the flask or the solution is titrated with potassium permanganate solution. So in here I have my KMnO4, and the concentration of my KMnO4 solution is 0.255. So I'll label that as well. Very good. Now, once we should recognize here, I recognize that if I have the molarity and the volume of a solution, I know that that's right away enough information to calculate moles as well. And once I have moles of oxalic acid, I'll be able to use my mole ratio between oxalic acid and potassium permanganate to figure out how many moles of potassium permanganate are required to react with all of those moles of oxalic acid. So let's do that first step. We know that molarity is equal to moles divided by liters, and we have molarity and we have liters. So to get moles, we'll just, of course, multiply just like that. So then what is my liters of oxalic acid? Well, it's that 20 milliliters. So I'll just write that in liters by moving the decimal place over. And my molarity is 0.803 molar. And I can figure out what my moles is right there. So I'll punch this in my calculator real quick. I got 0.01606, and that's moles of oxalic acid. All right, so all titrations are basically just a stoichiometry thing. We combine solutions until something has fully reacted. So you're always going to be using in some way a mole ratio between two reactants. And in this case, my two reactants are the oxalic acid and the potassium permanganate, which is said right here is a 5-to-2 mole ratio. For every 5 moles of oxalic acid, 2 moles of potassium permanganate are needed. So if this is how many moles of oxalic acid that I have, to figure out how many moles of permanganate solution are required to react with all of it, all I need to do is I need to figure out a number that is 2/5 of it. Right? What is 2/5 of 0.01606? That should be the answer, right? Because I know that however many moles of oxalic acid, it just takes 2/5 as many moles, right? You agree with me that 2 is 2/5 of 5, yeah? So I need the number that's 2/5 of 0.01606. So I'll punch that in my calculator real quick. I got 0.006424, and that is moles of potassium permanganate solution. Now my question is asking for something kind of weird here. It wants to know how much solution must have been dispensed into the flask in order to react with all of that oxalic acid. We know how many moles of permanganate now must have come out of the burette, but if it's asking how much solution, it probably wants it in milliliters because that's how the burette measures it. So now we just need to figure out how to convert from moles of potassium permanganate to milliliters of solution. And of course, for that, we're going to have to use the molarity formula again, but this time it's for the molarity of the KMnO4 solution. We know that molarity is equal to moles divided by liters. This time, since I'm solving for liters or volume, this is going to be liters equals moles divided by molarity. So then I just need to punch those numbers in to my calculator, and it'll give me the answer. So I'll go 0.006424 moles of KMNO4. And I will divide that by the molarity of my KMNO4 solution, which is known to us, 0.255 molar. And that should give me liters. All right, I got 0.02519 liters, which, if I convert that to milliliters, is 25.19 milliliters. Sig figs, this should go to 3 sig figs, so I'll go 25.2. And there's my final answer. Like I said, guys, this is way more complicated than anything that's going to be on the test. This isn't even an acid-base titration. It's like a weird other kind of titration that we haven't done. But I figured you technically had all the information you needed to figure it out, so I wanted to throw you a challenge one. And I hope that makes sense. If you have any questions about that, feel free to either leave a comment or talk to me in class about it.